Hi, this is Doug Fowler. Today we'll be taking a look at some of SysTune's operational features. Let's get started. The first thing we need to do is configure and select our audio device. So configure, select device, and here we see the device configuration options. I have a variety of standard Windows drivers available to me. I'm using today a PreSonus Firebox, so I will select the Firebox ASIO driver. I have no options for dynamic range over here, so that stays at 32-bit. And for a sampling rate, I have these available to me, but I will choose 44.1 kilohertz because I do not need frequency response greater than 22.050 kilohertz. It's outside the operating range of this loudspeaker, so take these options, hit OK, and that's it. Now let's look at some of the items on the SysTune control surface. In this area, we see the option to select the signal or normally microphone channel, and we can do that by selecting any of these. I have available to me 6 inputs on this device, so I can choose any of these. Today I have the microphone connected to channel 1. If we wish to do a multi-channel measurement, we select and deselect that here. Down here we have the reference channel, or normally the stimulus signal channel, and again 6 channels available to me, so I can select any of these if I wish. The out setting is to be used only when using the Easera Gateway or the Avion X.8 device. Selecting out causes SysTune to monitor its internal generator for a reference signal, but if you're not using one of these devices, SysTune is unable to tell what the latency is, and so the time offset will be incorrect, and that's a problem. So only use the out setting if you're using one of those 2 devices. Other items here are the delay offset for setting the delay between the signal and reference channels. We can zero it by clicking on this. We can set it to the peak of the impulse response by clicking this one, or we can put it in auto mode and it will cause SysTune to continuously track the peak of the impulse response. Directly below that is the calibrate dialog box, which allows us to calibrate the microphone with a known SPL source. Now let's examine the SysTune generator section. Play signal starts the generator, but before we do that, we have to configure it. Select, and here's our signal selection dialog box. For signal type, we have a linear sweep or a chirp, a log sweep, pink noise, or we can load a file into SysTune to use for stimulus with some limitations, which are outlined in the manual, so read that first. On the right-hand side, in the signal selection parameters, our sample rate is displayed for us here. Gain. SysTune will default to -6 dB digital full scale for the output, which is a pretty hot signal. I recommend setting it to -18 or -24 so you don't get a big surprise when you push the play signal button. Measurement length. In every case, we will set the SysTune generator signal size to the same FFT size that we select for our measurement. We'll do that shortly. So we've selected a 1.49 second time window for our SysTune generator signal, and we will do the same thing for the FFT size. And that's it for the generator section. Here we see the FFT size parameter section. The FFT sizes, or measurement time lengths, available to us are determined by the sampling rate. We will normally choose the time length, or FFT size, based on how long we wish the measurement to be. Measuring indoors or in small, non-reverberant spaces allows us to use a smaller time length. In reverberant spaces, we will need a longer time length to get the room response included in the measurement. In most cases, a time length of somewhere between 1 and 3 seconds will be sufficient. In any case, the FFT size should be as long as the decay time of the room under test. So again, if you are indoors and have to take the room response into consideration, use a longer time window. Averaging. Here we can tell SysTune how many FFT blocks to average together. For each doubling of averages, we get a 3 dB improvement in signal-to-noise ratio in the measurement. The downside is the analyzer becomes less responsive. For difficult conditions such as a noisy environment or subwoofer measurements indoors, infinite averaging can yield good results, but again, the trade-off is slow response. Just click the reset button to start the averaging process from the beginning. And that's it for the FFT size parameter section. Let's look at SysTune overlays next. An overlay is a method for storing information about a measurement you made. To capture a measurement, hit the Capture Measurement button. SysTune captures it and assigns it a name. The first is OV1, the second is OV2, and so forth. If you want the measurement to be available to you after you close SysTune, you must save it to disk. Do this by pushing the Save button and then complete the dialog box. If you exit SysTune and have unsaved overlays, SysTune will prompt you to save them. If you cancel at this point, SysTune will exit and your overlays will not be saved, so take this into consideration. To load a saved overlay into SysTune, use the Load button. Average is used to average overlays together in order to produce an averaged multi-channel measurement. If you wish to remove an overlay from the list of loaded overlays, use the Remove button. Note, this does not delete it from disk, but merely removes it from the list. Once the overlay is captured, we can do a few things to it. An important control is the V button. V stands for visible, and pushing this hides and unhides the overlay. We'll hide the overlay, which is directly on top of the measurement that we took. Now we'll hide the current measurement. Now the overlay is back. We can also change the color. The current measurement is still hidden. Behind the ... is a dialog box with some advanced options, including gain. These are covered in the manual. The Lock button locks the measurement from being affected by the SysTune Virtual EQ. That's it for the overlay section. Let's see how we can change the SysTune display. Zoom. Zoom in or zoom out. Using the mouse, left-click and drag in the horizontal axis to change the view. For frequency-based measurements, such as magnitude and spectrum, this zooms into a tighter frequency view. Like this. We'll zoom in from 100 to 1000 Hertz. Left-click, hold, drag it over, release. To zoom in the vertical axis, or in this case amplitude, right-click and drag in the vertical plane. Same way. Right-click here, hold it down, pull it down. We can do it again if we wish. Notice this box. When this is clicked, if both SysTune windows are displaying a frequency-based measurement, they will track each other. So if we now click drag, the windows will track when I drag them around. So let's do that. Drag. We're dragging left and right. Up and down doesn't do anything, but left and right, they track perfectly. To return to maximum view limits, either double-click in the viewing area or click this box. Let's double-click. Zoom in again so we can see what the box does. Like so. Click this box. Maximum limits. Peak. We can use peak to look inside time-based measurements such as impulse response and energy time curve. We can also use it to place cursors, but we're not covering that here. Let's go to the impulse response, the energy time curve view, ETC. We click the peak button. Now, go up here to the peak of the impulse response, click it, it's a left click, hold it, pull it down, and we can see that these 2 points in the energy time curve are about 0.4 of a second apart. One other control. Let's go back to the impulse response. Wrap at half length. This pulls the peak of the impulse response to the center of the screen so it's easier to work with. Normally we will leave this checked. It's currently checked, so if I uncheck it like this, we can see the peak of the impulse response move all the way to the left on the time scale. Now if I check it again, he comes back to the center. And of course we can zoom in on this if we wish. Okay, that's it. This should be enough to get you started. This has been Doug Fowler, and I will see you next time. Thanks for watching.